Welcome to this explainer. Okay, today we are diving headfirst into what is honestly one of the most fascinating technological arms races happening right now. We're going to break down exactly how modern insurtech is deploying state-of-the-art multimodal artificial intelligence to systematically dismantle complex insurance fraud. If you've ever found yourself wondering how an automated system can literally catch a liar over the phone or instantly spot a manipulated photo in milliseconds, well, you're in exactly the right place. We are going to go step by step through the architecture of a next-generation fraud detection pipeline. To really grasp why this technology is advancing at such breakneck speed, you've got to look at the sheer stakes involved. Right here in the US alone, insurance fraud causes an estimated financial loss of over $300 billion annually. That's billion with a B. It's a massive, persistent problem, and unfortunately, it drives up premiums for every single legitimate policyholder. The old, manual, rule-based systems, they just can't keep up with the volume and the sheer sophistication of modern fraud rings anymore. We desperately need advanced AI solutions to fight back. Okay, let's dive into this. Here is our architectural blueprint for today. We'll be walking through 1. Overcoming data privacy constraints. 2. Processing audio and visuals. 3. Narrative analysis with hybrid NLP. 4. Detecting fraudulent voice reuse. 5. Fusing signals for risk scoring. And finally, 6. Transparency through explainable AI. All right, starting with Section 1, Overcoming data privacy constraints. So here's the first major bottleneck we hit when building these systems. You literally can't train an AI without data, but real insurance claims are heavily protected by GDPR and other strict privacy laws, as they should be. So how do data scientists solve this cold start problem? The answer is synthetic multimodal datasets. They're actually using AI to generate hyper-realistic yet entirely fake claim data to train the system safely. It's wild. They use tools like the GPT-2 transformer model to whip up legitimate and fraudulent text dialogues. And they even include realistic speech disfluencies, the natural ums and uhs we all use. Then they use multi-speaker text-to-speech tools like XTTS to generate actual two-speaker audio recordings. It perfectly mimics real-world conditions, but it doesn't expose a single real customer's data. And this brilliantly illustrates that complete end-to-end architecture we're building. It's a fantastic bird's-eye view. The flow kicks off at the top left with that synthetic audio and text data ingestion we just talked about. From there, it moves smoothly through transcription, feature extraction, semantic analysis, and voice similarity, flowing all the way down to the bottom right, where it spits out a final weighted claim risk score. It's just a beautifully unified system. Moving right along to Section 2, Processing audio and visuals. Let's get into the ingestion phase. This is where we're going to give our AI system the ability to both hear and see the incoming claim. When a claim comes in via a phone call, the absolute first thing the system does is run that audio through WhisperX. WhisperX handles the speech-to-text transcription and a really crucial step called diarization. Now, diarization simply means separating the customer's voice from the agent's voice, so the AI knows it's analyzing the right person. Make sense? From there, named entity recognition, or NER, jumps in to pull out specific structural features like names, postcodes, and policy numbers. But hey, what if the claim is submitted online with a photo instead of a call? Well, that brings us to the computer vision aspect. When a customer uploads mobile photos or even drone footage, the system instantly routes them through convolutional neural networks. Specifically, it uses models like YOLO v5 for localizing exactly where the damage is, and ResNet 50 for classifying the severity of it. Within milliseconds, literally blink of an eye stuff, the AI analyzes those pixels to assess whether we're looking at a lightly scratched bumper or a totally cracked windshield. And honestly, even more importantly, it checks for image tampering. We're talking reused photos or digitally exaggerated damage. It instantly flags manipulated evidence that a human eye might easily miss. Which leads us perfectly into Section 3, Narrative Analysis with Hybrid NLP. Okay, so we've given the system its senses, right? Now it is time to give it an intellect. Traditional rule-based systems are, frankly, pretty basic. They just look for specific keyword matches to flag fraud. And organized fraudsters, they bypass those old rules in their sleep. Enter the hybrid NLP approach. This is a real game changer. The pipeline uses a fine-tuned BERT transformer model, paired directly with RAG. That's Retrieval Augmented Generation. What RAG does is allow the AI to take the current claimant's story and instantly search a massive historical database for semantically similar claims. It doesn't just look for matching words. It actually understands deep context. So if a highly unique, super specific story about a stolen laptop is suddenly popping up across multiple accounts, the RAG system connects the dots and flags that narrative reuse. Next up is Section 4, detecting fraudulent voice reuse. Now, what's really interesting about this is how it serves as a critical identity verification layer. This is specifically designed to catch organized, coordinated fraud rings that try to exploit call centers. We are talking about cross-modal verification. On one side, you have the text classification happening, but on the other side, we have voice clustering using Resymbolizer speaker embeddings. So Resymbolizer essentially takes the customer's voice and encodes it into a mathematical representation. By measuring the cosine similarity between these voice embeddings, the system can catch the exact same physical voice calling in to make claims under completely different names and policies. So if Daniel Wright calls in today and a mathematically identical voice calls in tomorrow claiming to be John Smith, the system instantly clusters them together as a high-risk fraud ring. No way around it. All right, Section 5, fusing signals for risk scoring. So the crucial point is, we have all these amazing, specialized AI modules working in parallel, but they have to snap together into a single unified brain to actually make a final decision. The big question is how we weight these incoming signals to prevent false positives and, protect the experience for honest customers. The system calculates a final risk score from 0 to 1 based on a very specific formula. It assigns a weight of 0.4 to structured features. These are your objective financial behaviors, things like early claims or missed payments. Then it assigns a 0.3 weight to narrative similarity and a 0.3 weight to voice clustering anomalies. By heavily weighting objective financial history right alongside the text and voice AI, the pipeline ensures a balanced, highly accurate risk assessment. And finally, Section 6, transparency through explainable AI. Look, in the highly regulated world of insurance, a high-tech fraud decision absolutely cannot just be a black box. If an AI system denies a claim, we have to know exactly why. It must be transparent, and it has to be human-readable. And we achieve this through explainable AI, or XAI. This automation loop basically creates an immutable audit trail. It allows a human claims investigator or an external auditor to trace any high-risk flag back to the exact trigger. The system explains, in plain English, whether the score spiked because the computer vision detected a forged timestamp on a photo, or maybe because the Resymbolizer embedding matched a known fraudster's voice. This keeps the human securely in the loop and ensures strict regulatory compliance. Building a system this integrated is definitely no small feat. As our sources from InsurNest accurately highlight, real-time claims fraud detection is a CTO-level problem. It touches the very architecture of the entire business. You simply cannot achieve this level of multimodal analysis by slapping on isolated departmental software patches. It requires systemic, platform-level thinking. You have to integrate API event streams, data lakes, and microservices into one perfectly unified pipeline. We've seen just how incredibly powerful this AI architecture is at defending against fraud today, but it leaves us with a provocative and maybe slightly daunting final thought. As the exact same generative AI technology used to build our synthetic training data becomes capable of synthesizing flawless, deep-faked voices and generated images in the hands of bad actors, how will our fraud detection pipelines need to evolve to catch the very AI that powers them? The arms race continues, for sure. Thank you so much for joining me on this explainer, and remember to always keep questioning the technology around you.